Assalamualaikum and hi everyone. So we are from Group F. We'll present about wind energy in Malaysia. So first of all, I'm going to introduce my group members. First is Akmal Hakim, then Akmal Irfan, Muhammad Fikri and Hajratul Syafiqah. So we are going through the introduction. Malaysia is exploring wind energy but face challenge due to its low average wind capacity of 1.8 meter per second. As of now, wind energy is not officially recognized under the Renewable Energy Act of 2011 and efforts are underway to assess its feasibility for inclusion in the feed-in tariff scheme. Despite the potential wind energy contribute minimally to Malaysia's energy mix and the government evaluation reflects a recognition of the need to diversify energy source. Next, we are going through energy policy for wind energy. First, we have feed-in tariff (FIT) scheme. The Malaysian government introduced a feed-in tariff mechanism to encourage the development of renewable energy projects, including wind power. This mechanism provides incentives such as fixed tariff for electricity generated from renewable source. Renewable Energy Act 2011, Malaysia passed the Renewable Energy Act in 2011 to promote the development and utilization of the renewable energy. The Act outlined the regulatory framework for the implementation of renewable energy projects, including the wind energy. And third is Sustainable Energy Development Authority, SEDA Malaysia. SEDA Malaysia is the agency responsible for implementing the country's renewable energy initiative. It administers the FIT mechanism and facilitates the integration of renewable energy into the national grid. So this is the legislation and regulation. For Renewable Energy Act 2011 (REA), REA is the main legislation that governs the legal framework for RE in Malaysia. In addition to REA, there are subsidiary rules, regulations and guidelines administered by SEDA pursuant to REA through the implementation of FIT. Next, Energy Commission Act 2011 (ECA). Though REA is the principal statute governing RE in Malaysia, there is another relevant legislation named ECA, which governs the technical safety and implementation of regulation and related to electricity sector. So this is the current trend of wind energy in Malaysia. For the current state of wind power in Malaysia, first for installed capacity as of 2021, Malaysia has an installed wind power capacity of 100 megawatt. However, this accounts for only 0.1% of Malaysia total energy mix. Next, the key project. The largest wind power project in Malaysia is the 50 megawatt Malakoff TT Energy Wind Farm in Johor. Other notable projects include the 30 megawatt Gobi Nova Energy Wind Farm in Sabah and 27 megawatt the Tanjung Tuan Wind Power Farm in Malacca. For the future prospect and opportunities, potential for growth, Malaysia has significant untapped wind resources, particularly in coastal areas. The government targets to achieve 20% renewable energy in the national energy mix by 2025. Present opportunities for growth in the wind energy sector. And then for the technology advancement, new technologies such as floating offshore wind turbine and efficient wind energy storage solution have the potential to revolutionize the wind power in Malaysia, making it more reliable and cost effective. So in the summary, wind power is a promising solution for Malaysia's growing energy needs. It provides a source of renewable, sustainable energy, while also stimulating economic growth and promoting environmental awareness.
Okay, so now let's move on to issues and challenges in wind energy. Okay, so we go to the point number 1 is intermittency. Why intermittency? Because unpredictable wind is one of the biggest challenges in wind energy. Second, power output may be impacted by unexpected changes in wind speed because of Malaysian wind speed is seasonal and very variable. Okay, since Malaysia is situated near the equator, where the wind regime is influenced by sea and land breeze. Okay, so now we go to the second point, which is the design of the wind turbine itself. It is difficult to create the best turbine design at lower cost and their environmental effect. It is vital to create wind turbines that emit less noise. It is required structural integrity to ensure the wind turbine design structural durability. Must be designed to function effectively in a range of wind situations, including strong and light winds. Okay, so we go to the third point, which is environmental. Wind energy can affect on the land surface, noise pollution, deaths of birds and bats, and greenhouse emissions. Okay, if the wind turbine is located at the sea, leaking oils or waste into the surrounding seawater can harm the living ecosystem of marine species during maintenance. Okay, average noise of the rotor is 105 decibel, and the latest model can reach to 110 decibel. Okay, you can see a figure here about the deaths of birds due to the collision with wind turbines, and the second one is the loudness of the noise of the wind turbine with respect to time. Okay, for the point number 4, which is cost and climate change. Since some turbines are located at offshore, which is highly risk to be exposed to category 4 or 5 hurricane or cyclone, so we need to consider the cyclone's impact on the wind turbine. So we need to design the turbines to withstand 60 meter per second of wind. So in order to design the withstand to 60 meter per second of wind, so the causes is increment of cost up to 20 to 30% of cost from the original cost. Okay, so we go to the last point, which is types of wind turbines. As we know, wind turbines has two types, which are horizontal axis wind turbine or HAWT, and the second one is vertical axis wind turbine or VAWT. So it is stated that HAWT limited to unstable physical structures and high material, while VAWT is low in power generation.
Hello, my name is Akmal Kimisardi. Now I will present about advantages and disadvantages of wind and renewable energy. Firstly, the advantages is clean and sustainable energy source. One of the foremost advantages of wind energy lies in its cleanliness and renewability. Secondly, mitigation of greenhouse gas emissions. Wind power plays a crucial role in decreasing the reliance on fossil fuels, thus mitigating greenhouse gas emissions. Thirdly, low operating costs. The operational expenses associated with wind energy are relatively low once the turbines are installed. 4. Job creation and economic impact. The wind energy sector fosters job creation across various stages, from manufacturing and installation to maintenance. Now, the disadvantages. First, intermittency and variability. The intermittency and variability of wind pose challenges for consistent power generation. Second, visual and noise impact. Concerns regarding the visual and noise impact of wind turbines have been raised by communities living in proximity to wind farms. Third, land use and wildlife impact. Large-scale wind farms require considerable land, impacting local ecosystems and wildlife habitats. 4. Initial capital loss. While the operational costs are low, the initial capital investment in wind energy projects can be substantial and high. Thank you.
Okay, I will continue for the statistics. So we can see this is top 10 wind countries. We have China, United States, Germany, India, Spain, United Kingdom, France, Brazil, Canada, and Italy. So what we can observe from this chart is we can know that this is for wind capacity in Malaysia. Malaysia wind capacity in 2021 is virtually negligible. IRINA estimate for Malaysia's wind power share, which is 0% of total energy mix. So we can compare with China. China installed wind power capacity exceed 300 gigawatt, and compared to India, India has upward of 40 gigawatt in installed wind power capacity. This highlights Malaysia's minimal presence in wind power compared to leading countries like China and India. So this is comparison between monthly mean wind speed data and the scale parameter over 3 years period at sites Mersing, Kudat and Kuala Terengganu. The wind power law serves as a valuable tool commonly employed to assess wind power in cases requiring adjustment of wind speed data from various height to standardized level. Notably, the experiment end of the power law is set to 0.5 for the Mersing site, accounting for ground characteristic, while wind data from MMD station Mersing were collected at height of 43.6 meters, data from Kuala Kudat and Kuala Terengganu, and conversion to a 10-meter height above the hub, aligning with the operational elevation of the wind turbine. And next, this is monthly and annual mean wind speed at the site Mersing, Kudat and Kuala Terengganu for the average years of 2013 and to 2015. Based on this study, the diagram below depicts the monthly and year average wind speed recorded at Mersing, Kudat and Kuala Terengganu sites during the year 2013 to 2015. These findings were projected to different elevation. Wind speed were extrapolated for multiple height, specifically the mean wind observation station 60 meters and 100 meters at the wind observation station located in Kudat, Kuala Terengganu and Mersing. The outcome obtained from this analysis are displayed as this figure. And this is wind power density for 2017 in Kuala Terengganu, sourced by Sabri at AL 2019. We can see that the wind power density is highest at December, which is 106.1 watt per meter square.
Hi, Assalamualaikum. My name is Hajatul Shabika binti Hardi, metric number B0421101114. I will explain for my part, which is fact about wind power, and also attach the link and figure for your better understanding. Okay, next, I will explain about the type of wind. There are two types, which is onshore wind power and offshore wind power. For onshore wind power, they are installed on land, often in open area. For example, plant, hills and others. Second type for offshore wind power. For this type, they are installed in bodies of water, usually in sea. It can be situated in relatively close to the shore or further out in deepest water. Okay, next, for your further understanding, this is the parameter for onshore wind power and offshore wind power, which is the parameter is efficiency, average lifespan and economic impact on job creation. For efficiency of onshore wind power is 25 until 40% and offshore wind power is 40 until 60%. Second, for the average lifespan for onshore is around 20 to 25 years with proper maintenance, and for offshore wind power is similar to onshore turbine with advancement potentially extend the lifespan. And lastly is the economic impact on job creation. For onshore, the wind energy sector employed over 1.2 million people globally in 2022, and offshore wind power is job creation is influenced by the scale of offshore project and local workforce participation. This statement is get from IRENA, which is stand for International Renewable Energy Agency, and EWEA, which is stand for European Wind Energy Association. Then this is the data for wind speed in Malaysia. The average of wind speed in Malaysia is usually below 3 meters per second. The average of wind speed below 3 makes it less potential for generating continuous wind energy output. The optimal of wind speed is 5 meters per second or more. The area that show the highest wind speed is in red and orange, while the other areas show moderate wind speed. Which is from this figure, we can see that the wind speed distribution for each area in Malaysia. Lastly, for the conclusion, basically in Malaysia, wind power holds promise in its renewable energy landscape, while not as prominent as other renewable sources like solar or hydroelectric power. Wind energy presents an opportunity for sustainability. The country coastal region has a potential for harnessing wind energy and advancement in technology to make wind power more viable and cost-effective. Investing in wind energy can reduce the use of fossil fuel and move the nation towards a cleaner and more resilient energy future. That's all from me and my friend. Thank you.